Here I will show a couple of demos of things we've done in the 5G, 6G Innovation Testbed. The first is a network resiliency demo where we do a denial of service attack on the network and use an orchestration tool to keep the network stable while using a threat detection tool to shut down the attack. So first we use the AMCOP orchestrator to orchestrate the 5G core. When we go into the testbed user interface, we connect the G node B, and we'll just confirm in Grafana that it's connected. Then we'll go back to the user interface and register some UEs to the network. In this case, 6 UEs just to set a baseline of traffic. Now, if we go into Nixon's net mobility monitoring software, it says that traffic is normal, just those 6 UEs. But when we initiate the denial of service attack and go back, we have an alert, a high number of NGAP messages. Now, first, if we go and look at AMCOP, we'll see that AMCOP has already scaled up the network to protect users. Meanwhile, the traffic storm, the denial of service attack is mitigated. And when we go back to AMCOP and Kubernetes, we see it has scaled down the network. Now, the great thing about this scenario is we see that the time and duration of the attack was very short because the net mobility monitoring software recognized it, mitigated the attack, and took care of it. But at the same time, right when the attack happened, the orchestration tool enabled by AMCOP scaled up the network to make sure that those 6 UEs didn't get denial of service, that they maintained service on the network. And as soon as the attack was shut down, AMCOP also recognized that the threat was gone, that traffic was back to normal, and it could scale down the network so that we weren't overusing resources or wasting money. And so this is a very nice demonstration of not just attack detection and mitigation, but also multi-cluster orchestration, closed-loop automation, and lifecycle management. In this demo, we are going to look at dynamic quality of service modification that's enabled by the Camara project, and we'll stream a video through the network and then create congestion in the network that degrades the quality of the video. But we'll use an API to modify the DSCP value, and that will improve the quality of the video. So this is the video streaming without congestion. And if we look in Wireshark, there's no special marking done on the packets. But then if we go and use a tool called iPerf3 that we've enabled in the testbed, it will create congestion and the quality of the video suffers. Okay, now then we can go and use an API created and enabled by the Camara project, and in the testbed UI we can configure the DSCP rules that the API has set. And when we play the video with congestion, the quality improves, and we can look in Wireshark to see exactly where the packets were modified to make the video look better. So this is a side-by-side comparison. This is before congestion, this is during congestion but without any special marking, and this is with congestion but also with the API doing its work to tell the network that the streaming video user needs to get better quality of service assigned to it. And you'll really see that the two on the top are very hard to tell the difference between, whereas the one on the bottom lags behind, is lower quality, and generally looks bad. And so it's a nice simple demonstration, but a nice demonstration to show how you can use tools like APIs to teach the network how to treat certain users over others when maintaining quality of service. And it's just one of many tools that our users can take advantage of in the IEEE testbed to do scenarios or use cases like this one. Do a demo of the IEEE 5G 6G Innovation Testbed user interface. And when you log into your account, the first thing you'll see is the dashboard. Now this is actually a live look at your network in the cloud as it exists at that moment. So it's not just a static picture. Right here it says Gnode B connected. If it were not connected, it would be red and it would say disconnected. Same for all your network functions. Right now they're all running. If they were not running, it would say so here. And you can click on a network function and get certain information about it. The dashboard also shows you the status of certain use cases, whether they're enabled or not, and certain tools that are common to use, whether they're enabled or not. So you could just check everything before you get to work and make sure everything that you need is up and running. But most of the work, or a lot of it, will get done here in this testbed section. So if we go to the Gnode B, it will pop up the status of the Gnode B, the configuration, and I can check the configuration and see if there's anything I need to change. In the information, it will update to show an updated or live look at your Gnode B, and in operations you can take certain actions like download information about the Gnode B to a text file, disconnect it, or release UEs. Now in the UE section, this is a list of all the UEs or IMSI numbers that have been assigned to this user. And the dark blue ones are not connected to the network, the light blue ones are. And so, for instance, if I click here, register UE, I can register an additional UE to the core, and then if I go into operations, it will show me only the two that are connected. And if I were to hover over the eyeball for this one, it says view UE details, and I can get a lot of information about it, like the status, the timers, coverage, and the tunnel info for what tunnel is carrying data and so forth. I can also take actions like get an open speed test on that UE, establish a PDU session, dump UE information, again a text file that I can look at offline, or deregister the UE. So if I click deregister, it'll be taken away and is no longer connected to the core. For the core, I can go in here and get an updated and live look of the status of my core. This list are all my 5G core network functions. They're listed as called pods because they exist in a Kubernetes cluster, and pods is the name used by Kubernetes. But for instance, here's my AMF, and I can click it and get information about my AMF, but I can see that they're all running. In addition, in the core section, in the configuration tab, I can add new UEs or new IMSI numbers to this user to test or develop with. That can happen in bulk if you want to upload a large number of UEs to a user. In logging, I can log my different network functions at the hour, minute, or second level. And then in call flows, these are static sample call flows and other procedures or functions. So for instance, here are the network functions, and we have sample registration and PDU session establishment examples, right? So you click on it and you could see the sequence diagram for this network function, which is the UPF. And if I click download, I can download it and then open it in a piece of software that can view PCAP files. Now tracing is where we can start to record certain actions for analysis later. So if I were to see start trace, I'll say trace demo and click start trace. My trace has now started. So now whatever action I take will be recorded. So if I go back to the UE section, let's say I register this UE, and I'll register this one as well. And then if I go to operations and I remove or deregister that first one, Now let's go back to tracing and let's stop the trace here. Trace has been stopped and has been saved. And so now if I look at view trace, I get the sequence diagram for what I just did. I registered 2 new UEs to the network and deregistered 1. And this is the sequence diagram of everything that happened behind the scenes. It's something that you can study and save. You can also download it again and open it in a program that can view PCAP files. But another thing you can do with it is go to, in the tools section, we have a tool called Trace Analyzer. And you can add your traces to the Trace Analyzer, and rather than have it just be a static sequence diagram, it turns it into a interactive sequence diagram that's much easier to navigate and click to different sections and get detailed information about what's happening at each step in the process. So if you do create much more complex and detailed trace recordings, the Trace Analyzer will be a much better tool to review everything that happened. In monitoring, going back to the testbed section, we give access to the Grafana dashboard, and that will be helpful for anyone who wants to look at certain metrics repeatedly. Grafana will give you a very highly customizable dashboard with an extremely long list of metrics that you can add to your dashboard. And so, our dashboard is going to remain pretty simple, just the G-Node-B and your network functions. But Grafana will allow you to add different metrics for a live look at your network and the work that you're doing. We'll go to the use cases section on the left nav, and the Chimera API project has been integrated with the IEEE Testbed, and we have made several APIs available and able to use and test and develop with right within the user interface, and we will continue to add more as they become available or as people develop new APIs or as they become requested by our users. We also have a section for network slicing that will allow any user to easily set up which slices they want to have deployed or not. For standard accounts, we typically give any new customer 4 slices, but there's really not a limit. You can certainly add more if you need more than 4 slices to test with in your network slicing testing. And then in the tools section, we've integrated the basic Linux terminal. If you need to do work with that, you can do it right within the user interface. The traffic control tool will enable you to manipulate the traffic in your test using the emulated RAN and emulated traffic. So you can introduce delays or certain latency scenarios or even corruptions in the traffic. Network test is another utility we've added. It's a tool called iPerf. This can allow you to inject congestion or other different types of network and traffic scenarios. Open speed test is a tool that is popular, so we added it directly to the user interface. We've already talked about Trace Analyzer. And then we have a user interface to set up denial of service attacks. And here you can define things like the burst rate, duration, and wait period so that you can run these denial of service attacks and then change some of these components and then see how the network reacts or maybe you have a security tool that you're testing, and you could test it with different burst rate durations and wait periods. So if the burst if there are 5 bursts that each last 30 seconds and there's a wait period of 2 minutes in between each burst, then you can test your security tool if the burst rate was 15 seconds but a duration or the burst rate was 5 bursts but a duration of 10 seconds and a wait period of 3 seconds between them, just to see how the network and your tools respond. And then lastly, we have this resources section, which is helpful for users in the sense that it is all of the manuals and user documentation that we have developed as we've deployed new things to the testbed. So for instance, there's the new user onboarding guide. It is right here. You probably wouldn't want to read it within the web interface, but you can of course download it and read it offline or in a tablet. But the important thing is that it's accessible right here, and you know it's always there for you. Same goes for different things like the manual for the testbed user interface, Camara API user guide, a guide for network slicing, so on and so forth. And then for those who prefer video tutorials over readable manuals, we've added videos to this section where this is a sort of demo or tutorial on network slicing within the user interface. We also have videos for Camara API, traffic control, video streaming, and more. And these resources always get, every time we create new functionality, we'll add resources to back up that functionality so that people know. That pretty much concludes the quick tour of the testbed user interface. And of course, you don't have to use the user interface. Pretty much everything that you can do in the testbed can be done from the command line interface. And so if that's your preferred mode of working on things, you can of course still do it that way.